Welcome to the first in a series of videos where I'm going to model how to tackle some of the really challenging style of questions that you might see on the quantitative chemistry topic at GCSE chemistry. The first video I'm going to look at using relative formula mass and Avogadro's constant in order to tackle quite a challenging question. So I've got the question here in front of me, and it says that Avogadro's constant states that 1 mole of a substance always contains 6.02 times 10 to the power of 23 particles. Calculate the number of molecules in 240 milligrams of methane, which has the formula CH4. Give your answer in standard form and to 3 significant figures. And to help us here, we've been given the relative atomic masses of carbon and hydrogen, and you can see it's worth 5 marks. So after reading through the question, the first step is bugging the question, which stands for box the command word, underline the key parts of the question, and then go over it once you've finished and also come up with a little bit of a plan in order to help you answer it. So let's highlight the key parts of this question. Avogadro's constant states that 1 mole, so I'm going to underline 1 mole of a substance, always contains 6.02 times 10 to the power 23 particles. Now, in this definition, we're using that word particles quite carefully because Avogadro's constant applies to atoms. It applies to, it could be ions we're talking about. It could be molecules, as is in this question. So that word particle is used as a general term for this constant. Calculate. So that's our command word. That's what's telling us what we need to do in this question. We need to do a calculation. Calculate the number of molecules. So it's just the total number of molecules in 240 milligrams. I'm going to circle that number there. Now, straight away, there's some alarm bells ringing in my head because the standard unit that we use for mass in chemistry is generally grams. But here we've been given the mass in milligrams. So already that's telling me at some point I'm going to need to do a cheeky little conversion into grams. So 240 milligrams of methane. So always underline the chemicals that it's talking about. Give your answer. So again, give is an example of a command word there. In standard form. And to 3 significant figures. So at the end, we're going to need to check our answer to make sure that it's in 3 significant figures. And as I said before, this is worth 5 marks. So in a moment, we'll have a think about how we can break down those 5 marks. To start off with, though, we need to remind ourselves of one of the key definitions about the mole in order to help us answer this question. And this is one that you need to learn, and it links into an equation that you need to learn as well. So one definition of a mole of substance is that it always contains 6.02 times 10 to the power of 23 particles. But the other definition that you need to learn is this one. 1 mole of a substance is equal to the relative atomic mass, I'm going to abbreviate that to AR, or the relative formula mass, the MR, in grams. So that is a key definition that you need to learn. And from that definition, we get a key calculation, a key equation that you also need to learn. It won't be given for you on your data sheet. So this tells us that the mass of a substance will be equal to the number of moles of that substance multiplied by the relative formula mass of that substance multiplied by the MR. So it's this equation that we're going to need to use in order to help us answer this question. Okay, so I'm just going to move my camera down a bit. So let's go about tackling this question. Well, I've already highlighted that we're going to need to do a conversion. So let's get that out the way to start off with. So 240 milligrams will be equal to, well, we need to know how many milligrams there are in a gram. Okay, and just like there are 1,000 millimeters in a meter, there are 1,000 milligrams in a gram. So in order to go from milligrams into grams, we need to divide this number by 1,000. And if in doubt, put it into your calculator. 240 divided by 1,000, that gives us 0.24 grams of methane. So we know the grams of methane now. In order to get the total number of molecules, we need to know how many moles of methane we have, because after all, 1 mole contains a fixed number of particles. Now we don't yet know the moles, but we know the mass, so I'll just put a little tick up by the mass. We don't know the moles yet. What about the MR? Well, the MR, remember, is a really simple calculation, and they've given you the atomic masses of carbon and hydrogen, so you need to add those together in the ratio that we can see in the formula for methane to get the MR. So we'll do that next. The MR of methane will be equal to 12 plus 1 plus 1 plus 1 plus 1. So the MR will be 16. The relative formula mass will be 16. So we know the MR. And because we now know the mass and the MR, we need to rearrange this equation in order to work out the moles. So just remind you a little bit of maths here. We want to get the number of moles by itself. So we need to divide both sides by the MR. And that gives us mass divided by MR equals the number of moles. Okay, so we can now do that calculation. We've got 0.24 grams divided by the MR, which was 16. So again, let's put that into our calculator. We've got 0.24 grams already on there, divided by 16. That gives us 0.015. 0.015 moles. Okay, so now we know the number of moles, we can use Avogadro's constant in order to work out how many particles that will be, because 1 mole contains 6.02 times 10 to the power 23 particles, okay, or molecules in this case. But we don't have 1 mole, we've only got 0.015 moles. So all we need to do is multiply that by Avogadro's constant. I'm just going to move my camera down again. So to work out the number of molecules will be equal to 0.015 multiplied by 6.02 times 10 to the power 23. So again, I'll put that in my calculator. Multiplied by 6.02 times 10 to the power 23. That gives us 9.03 times 10 to the power of 21. Okay. Now, let's just check the other things we had to do. It says, give your answer in standard form to 3 significant figures. So let's just check that final answer. 1, 2, 3 significant figures. Yes, so in this situation, I actually don't need to do any rounding, but often you would have to round that. Is it in standard form? Well, my calculator's already put that in standard form, times 10 to the power of 21, so I don't need to do anything else with that. So let's just have a think about where the marks would be picked up for that question. It was worth 5 marks. So 1 mark would have been for this conversion here. So let's put a little tick there. 1 mark for calculating the MR. A tick there. 1 mark for calculating the number of moles. A tick there. 1 mark for multiplying it by the number of moles by Avogadro's constant. Tick there. And the final mark for presenting your answer in standard form to 3 significant figures. There we have our 5 marks. Okay, so in the next video we're going to look at how we can use this formula up here that links mass, moles and MR in order to predict the reacting masses in some reactions. Hope you found this video useful. I shall see you next time.